Hello everyone, welcome to Metallurgy by C. Patel. Today we will discuss about von Mises criteria and Tresca criteria of yielding. The question which I have selected is, if the yield strength of steel is 950 MPa, determine whether yielding will have occurred on the basis of both the von Mises and Tresca condition. The stress state is given by this 0 0 300 0 minus 400 0 300 0 minus 800 MPa. So here the stress state is given. So we need to find first through the von Mises criteria. When we see von Mises criteria, we will use the formula sigma naught equal to 1 by root 2 sigma x minus sigma y का whole square plus sigma y minus sigma z का whole square plus sigma z minus sigma x का whole square plus 6 times tau xy square plus tau yz square plus tau zx square to whole power 1 by 2. So this formula will be used in this condition because we have been given tau xy, tau yz and tau zx. There is one more formula which is related with principal strain, that is sigma naught equal to 1 by root 2 sigma 1 minus sigma 2 whole square sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square 1 by 2. So you can use this formula also, but to use this formula we need to first find sigma 1, sigma 2 and sigma 3, and this we will find it to compute for Tresca condition. So now first let us use this formula and predict whether yielding will occur or not. So putting the values, sigma naught equal to 1 by root 2 sigma x is this one, this is sigma y, this is sigma z, this is sigma x, this is sigma y, this is sigma z, tau xy, tau xz. These are the things. Now putting the value 0 minus minus, so plus 400 whole square plus minus 400 plus 800 whole square plus minus 800 minus 0 whole square plus 6 times tau xy, that is 0 whole square, tau yz, that is again 0, plus tau zx, that is 300 square by whole root. Okay, if you calculate this using calculator, then it will come around, do the calculation by yourself, it will come around sigma naught equal to 866.025 MPa. Okay, and we know according to von Mises criteria, this sigma naught, if exceeds this yield strength, then yielding will occur, because this von Mises criteria is based on stress which is applied in a single direction, in unidirection. So all the stress state which are given here is assumed to give a response similar to unidirectional state of strain. So in unidirection it is written as sigma naught, which is if greater than yield strength, then yielding will occur. If it is smaller than yield strength, then no yielding will occur. So here 866.05, so here 866.025, which is sigma naught is less than, that is 950 MPa. This was the condition. So yielding will occur here. Since sigma naught is smaller than 950 MPa, so what is the answer? No yielding will occur. Okay. Now for Tresca condition, we need to first remember the condition. The formula is tau naught equal to sigma 1 minus sigma 3. Tau naught equal to maximum shear stress which is reached in the material, and sigma 1 is equal to minimum principal stress, and sigma 3 equal to maximum principal stress. So in this condition we'll have to find sigma 1 and sigma 3. We can't use sigma x minus sigma y. So to do that, we need to first find sigma 1, 2 and 3. So to do that, we need to remember, let's just sigma represent principal stress. So we will use this technique. 0 minus lambda will subtract sigma from all the normal stresses, that is minus 400 minus sigma minus 800 minus sigma, and the rest will be same: 0, 300, 0, 0, 0, 300. Okay, we'll do first and take the determinant, and determinant of this should be equal to 0. Okay, so if we do this problem, then equation will come like this: minus sigma minus 400 minus sigma into minus 800 minus sigma, okay, minus 0. Then here if you take this one, first this, second this, minus 0, then whole will be 0 into 0, so 0 minus 0 plus 300, will take 0 minus 300 into minus 400 minus sigma. Okay, now, and this should equal to 0. So on further calculation, we will come to an equation which will be equal to sigma cube plus 1200 lambda square plus 23 lambda minus 2300 lambda, or I have taken written as lambda, so it will be just sigma, so write it as sigma minus 3600 equal to 0. Now you need to find the roots of this quadratic equation. So you may use the calculator, the scientific calculator which we have, but in the examination you will not be given the scientific calculator which you possess. There will be a manual or calculator will be there on the screen. So during that I think it will be difficult to find the root. So now you can predict the root. If you take sigma equal to 100 and then you solve this, so the roots will come. I am going to write the roots, total roots. So sigma 1 will be equal to 100, sigma 2 will be minus 400, sigma 3 equal to minus 900. Okay, so these are the roots of this equation. Now applying Tresca condition, it says tau naught equal to sigma 1 minus sigma 2, sorry, sigma 3. So here sigma 1 is the maximum principal stress, so maximum principal stress is 100. So 100 minus is the minimum principal stress, so minus 900 is the minimum one, so we'll write minus 900. So this will give 1000 MPa. And if you see, this 1000 MPa is greater than the yield strength. What is the yield strength? We have 950 MPa, so this is greater than 950 MPa. So yielding will occur. Okay, now coming to the next problem. Next problem you may be asked in examination, and one question has been asked on the hydrostatic stress. To find the hydrostatic stress, you need to remember the formula. Sigma hydrostatic is equal to sigma x plus sigma y plus sigma z divided by 3, and this is also equal to sigma 1 plus sigma 2 plus sigma 3 by 3. So from here, sigma x plus sigma y plus sigma z equal to minus 1200 divided by 3 is equal to minus 400 MPa. Okay, so you just need to take the average of the principal stress or the normal stresses. And one more theory you need to remember is that sigma 1 plus sigma 2 plus sigma 3 plus dot 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 is equal to sigma x plus sigma y plus sigma z plus dot dot dot. Like the sum of the principal stresses is equal to the sum of the normal stresses. This is always true. So you need to remember this formula also. Since we deal generally in 3 dimensions, so it will come around sigma 1 plus sigma 3 is equal to sigma x plus sigma y plus sigma z. And so this is the formula. Okay, thank you.